And welcome back. As we go ahead and dive right into our next look at loops, we previously have looked at the while loop structure, but now let's go ahead and take a look at the for loop, which is going to be similar, but there's going to be a little bit different implementation as to how we use it. So when we start talking about for loops, all right, remember that, again, these are loops, so they're going to accomplish the same things that we were able to do with while and do while loops, which is to eliminate repetitive tasks. Now, a for loop is generally used when we say, hey, you know what, we know how many iterations we want to increment through it. How can we solve this problem? Whereas like while loops, a lot of times it's more times for like a range of values, or it may be certain things that we do not know. Now, it doesn't mean you can't do the same thing with a for loop. However, that is a lot of times when you are going to use a for loop over while loop because you know how many iterations, or you're expecting to know how many iterations you're going to have. And if we look at this example here, we have int sum equals 0 and another int called next. And we're saying, well, for next equals 0, next is less than or equal to 10, next plus plus. Sum equals sum plus next, system out of print line, sum up to next is sum. So just in this case, it's just a simple adding program, kind of like what we looked at in our last examples. So we actually want to look at how that for loop is working. What are the pieces we need to make that happen? Well, there are three parts inside of a for loop, and those parts are separated by semicolons. For int count equals 0, count is less than 10, count plus plus, and then we have curly brackets. The first chunk of that, so the int count equals 0, that is what is known as the initialization. This takes whatever variables that we need to initialize and gives them a starting value. And of course, if we look at the above example, you'll notice that count is only going to be 0 once. It doesn't mean every time we go through that loop, we're setting count back to 0. Instead, it just means when I start the loop, count will be 0. After we've gone through that first iteration, it's going to increment, because you look at the end, you can see we have an incrementer there. The second part of the loop is the Boolean expression. This acts as a check for how long do we want this loop to run. In this case, once that loop hits 10, it's going to follow the loop. Now, I could, of course, set that to another variable, for example. Maybe I have another variable that is going to be from a user input. So, for example, it might be loop length, and that's going to be getting from a kb.nextInt. No problem. We could still have it function exactly the same, but just be count is less than that, and we would have it just execute accordingly. So that doesn't change whether it is a hard-coded value like we see here, or it's one that's derived from either the user or some kind of program function. It just has to be a Boolean expression that we can use. And inequality such as this is the most common way you'll see it. Now, the third part is what's known as the update, which is going to increment or decrement the variable in the Boolean expression. So in this case, we have count, and we want to say, hey, you know what? We want to control count with either adding or subtracting. Now, a key thing here to note is that the increment and decrement doesn't happen right away. Because remember, I said when we start this program, the count is going to be 0. Instead, it's going to go after the code inside the loop has been processed. So it has to go through a full iteration of that loop from start to finish. And then when it starts that next iteration, so the next cycle, so it's going to go from count equals 0. In this case, so then the second iteration, because we have count plus plus, it's then going to plug in count is 1. And it will keep going until it hits where it says count is 10. And when it hits count is 10, it falls out of loop because it never meets that condition. Now, the thing we need to talk about with that loop structure is something what's known as a local variable. The variable used in the for loop can be declared either inside or outside the for loop. So this is kind of a nice, cool thing you can do with loops. So I could either say for int I equals 0, I is less than 5, I plus plus. Or I could say int I, and then say for I equals 0, I is less than 5, I plus plus. Both of these are correct ways of implementing your code. Now, when constructing for loops, a lot of times we're going to declare inside the for loop, all right, our variable. So in this case, the first iteration, so for int I equals 0. Because a lot of times that variable for where we're starting is something that is going to be initialized to some starting value like 0. So it doesn't matter what is. Now, there are, of course, times where maybe we want that starting value to be, for example, the user is going to enter that value. And so in that case, you would have the second case where int I equals 0. So you could go ahead and predefine that through the user rather than through your program code. So there are, of course, times you want to use both. Additionally, one thing I want to point out is that any variable for our loop that gets used, it's best to use a name that can make sense. All right, so such as the variable count would be a good one. Or we can use the convention of I, which is a lot of times used for a incrementer variable here. So that's why we use I. And the reason why this is called a local variable, because if we look at here in this first example, that int I equals 0 only exists within that loop. And that's a lot of times one of the strengths of why people use this version, because we don't care about what that value of I is after we leave that loop. So a lot of times they'll localize it to exist only within this for loop. Kind of like when we looked at the couple of our loops before, we said if it only exists within that loop, it's never going to happen beyond that. Now, let's take a moment to kind of take a breather on the semantics of a for loop. All right, and just so that we have a nice, good refresher, because again, these are going to function a little different than how our while loops are. The first thing a for loop does, it initializes. All right, so it's going to take that variable, that local variable we just had, it's going to initialize it to some value. Then it's going to test the Boolean expression. So even if it's the very first iteration of that loop, the first thing it does, regardless if it's the first iteration or the last, is it tests the Boolean expression. And so let's just say we have int I and we're going to I is less than 5. Well, if I starts at 0, it's going to hit that Boolean expression and evaluate as true. If I started at 6 and it says I has to be less than 5, well, it's going to evaluate to false. And if it evaluates to false, it falls out of the loop. If its value is just true, well, then it's going to do whatever code is inside the body of that loop, and then it's going to update. So it's going to go ahead and increment or decrement that value that we're using to keep track of our loop. Now, it's very easy to convert a for loop to a while or a while loop to a for loop, and there are ways for both of them to be a better implementation, but the process of doing so is pretty easy. So for example, we look at this one, we have for number equals 100, number is greater than or equals 0, number minus minus. All right, this is how many bottles of pop we have left sitting in the cooler, so that's quite a bit of a pop. While number is greater than or equal to 0, so on a print line number of bottle of pop, we can see we have the exact same thing. Biggest difference here, you'll notice, is that here we don't have number equals 100 here in our while loop, which means that that was probably declared outside the while loop. All right, so that's one thing you have to keep in mind, that here we don't know the starting value for a while loop, so it's always going to be declared outside our while loop. Our Boolean expressions, you notice, are exactly the same though, so that is pretty nice. We don't have to try to think what is the Boolean expression. So for example, if I was going from this while loop to this for loop, I don't have to think about what the Boolean expression is because it's going to be exactly the same. And you'll also notice that my incrementer or decrementer before here is up in the loop header, whereas like here it ends up inside the actual loop body. So those two big differences right there is, you know, those things that you look when you're trying to convert from either a for to a while or from a while to a for loop. Both of these loops ultimately, though, accomplish the exact same thing. They're both going to have the exact same outcome. It just ends up how you end up implementing it. Again, a lot of times you'll see these used is when you know the number of iterations of for loop, a lot of times lends itself really well. Whereas if you don't know the number of iterations, or it's going to be something like an infinite run, a while loop might be an easier iteration for that. Now, there is a way for us to test multiple conditions with for loops. And we can do that using a comma to initialize multiple actions. So for example, I can say for term equals 1, sum equals 0, term is less than or equal to 10, term plus plus, sum equals sum plus term. In this example of the loop, the term variable is initialized to 1 and sum is initialized to 0. This, of course, keeps the variable to be used by the loop only, and of course its value is going to be inaccessible in the rest of the program. Now, there is a downside when we start looking at variables and Boolean expressions to having multiple conditions passed within to a for loop. First of all, we can't declare multiple types if we're using a comma inside of the for loop. So if I say for int term equals 1, double sum equals 0, term is less than or equal to 10, term plus plus, we're going to get an error because, you know, sum is a double type and not int type. Because you look here, it says int term equals 1. Well, that's declaring term to be an integer, and sum should then be an integer, but it's not. All right, it's a double type, and because you have two different types, you technically would need a semicolon here, and that wouldn't work because then the for loop's going to, after it sees that first semicolon, go and look for our Boolean expression. It's not going to see it. So if we wanted to try something else, we say, well, let's if we move double outside of that loop, all right, and say, well, double sum for int term equals 1, sum equals 0, term is less than or equal to 10, term plus plus. Well, we have a similar issue because even though we have now moved the double declaration outside, sum is still a double. All right, so ultimately, it's safest for us to, when we start dealing with the comma operator, to declare all our variables outside, just so that we don't have to worry about this type value issue here. Additionally, while we can only test one Boolean expression here, and notice in all these examples, there's only one Boolean expression, you can contest multiple conditions for a Boolean expression with and or. So if I wanted a compound Boolean expression, I could put it up here, and that could work for the test of my for loop. Now, one last thing to talk about is the extra semicolon. This we saw a little bit when we looked at with while loops. We don't need to place a semicolon at the end of a for loop. Just like with while loops, it's not something we do. Obviously, do while has a little different syntax. But if we look at the following example here, one of the things you'll notice with this for loop is that we place a semicolon here right at the end of the header. All right. If that semicolon got missed for some reason, we put a semicolon there, it's like, well, we're going to expect that loop to output hello 10 times. It's not necessarily going to perform the way we expect to. All right. A lot of times it'll say, hey, this loop is empty. It's going to skip right into the next code. So whenever we're dealing with loops, my recommendation is always to avoid trying to use a semicolon ender in there. Instead, use your curly brackets always for both for loops and while loops, because it's just going to end up working better. And just real quick, I'm going to go ahead and show a super quick for loop example. So let's go ahead and, for this example, let's go ahead and simply just get some keyword input with a loop. So let's go ahead and do a for, and I'm going to say int I equals 0. And so I'm going to create a local variable I. And I'm going to have I run to where it's less than. Let's go ahead and make this for 5 iterations. So I is less than 5. And I'm going to do I++. So that means every time it goes through this loop, it's going to add 1 to I. And then what we want to do from here is, let's just say we want to add numbers into num here. So we're going to get KB and we're going to add them in. So let's go ahead and say num to plus equals. And we're going to say we need a variable for our keyboard here. So what is going to be that value? So we want to do kb.nextInt, so that could just go ahead and get the next number from the keyboard. Probably want to add a quick prompt here, so system.out.println, enter a number to be added to the sum. And again, it's going to get that value from the keyboard. It's going to add it back into num. And then let's just go ahead and have it after the loop, go ahead and print out that value. All right. Now, if I were to put this value as is, and let's just go ahead and run this. So let's just go ahead and add up 5 numbers. We get 15. If I put this print line statement inside the loop, and this is where we start talking about things being contained within a loop block or not, what it's going to do, it's going to go ahead and print out this every time I type it in. So if I start typing this in, you can see it's pretty much just echoing my input, and we never get the actual total. So that's just one thing to keep in mind. If we want to do something like, let's say we're troubleshooting and we want to see what's happening inside the loop, we would put our print line statements here inside the loop. If we want it so we can just get like what's the end product, we can put that outside the loop. But again, it's very easy and very similar to what we did with while loops, except we just have a little different format that we have to follow.